According to the United Nations Food and Agriculture Organization, total emissions from global livestock amounts to the equivalent of 7.1 gigatons of carbon dioxide per year, which is 14.5% of total anthropogenic greenhouse gas emissions. These emissions are due to feed production, land use, methane produced by natural cattle digestive processes, manure storage, and general processing and transport. Cattle reared exclusively for beef are responsible for 41% of total livestock emissions. Over the past few years, there has been a substantial increase in demand for plant-based products due to environmental, health, and animal treatment concerns. While there are only a few studies specifically documenting consumer vegetarian preferences, according to Mintel's Global New Products Database, the number of vegan food products available in the UK doubled from 8% of total food products in 2015 to 16% in 2018. Similarly, the number of patents filed globally for meat substitute products increased by 34% from 2017 to 2018, indicating a clear rise in vegetarian trends. Against this backdrop, the Impossible Burger, a plant-based burger that looks, tastes, and smells like beef, was launched in 2016. According to Impossible Foods, the Impossible Burger contains 19 grams of protein, which is the same quantity as a beef patty. This protein is primarily derived from soy protein concentrate, which is created by treating soy flakes with alcohol or acid to remove soluble carbohydrates and substances like lectin and glycinin, which are considered to be anti-nutritional factors. Interestingly, and potentially surprisingly to meat lovers, soy protein has a higher quality rating than beef does. This is due to the variety and quantity of amino acids contained in soy versus beef. The Food and Agriculture Organization and the World Health Organization have adopted the Protein Digestibility Corrected Amino Acid Score as the best method of evaluating protein quality for human nutrition. This scoring method compares amino acid content in a protein with the essential amino acid requirements for a preschool-aged child, and then scores the protein based on how its first limiting essential amino acid matches the average child's needs. On a scale of 0 to 1, soy beats out ground beef with a score of 0.95 to 0.92. While some believe that you can only get a complete protein with all 9 essential amino acids from meat, soy is in fact a complete protein and provides all the amino acids that the human body needs. The most interesting part of the Impossible Burger is its meaty taste. According to Impossible Foods, meat flavor is derived from hemoglobin, the iron-based protein responsible for binding and transporting oxygen throughout animal bodies. In order to keep this ferrous flavor in their burgers, Impossible Foods identified leg hemoglobin as a plant-based source of heme. Leg hemoglobin is an oxygen carrier that is actually found in the nitrogen-fixing nodules of legumes. It is used to supply oxygen to nitrogen-fixing bacteria and to protect nitrogenase, which is an enzyme required for nitrogen fixation, from oxygen-induced deactivation. In meaty foods, hemoglobin and myoglobin are denatured by the heat of cooking and then unfold to expose their heme cofactors. The heme cofactor, in turn, catalyzes reactions with the variety of amino acids, carbohydrates, and other compounds found in animal tissue to create meat's distinctive taste and smell. Leg hemoglobin, which contains the exact same heme cofactor as animal hemoglobin, undergoes a similar unfolding during cooking and catalyzes a parallel series of reactions that gives the Impossible Burger its meaty flavor. While Impossible Foods originally obtained leg hemoglobin by extracting it from soy root nodules, they later developed a more efficient heme production strategy by genetically engineering yeast. Impossible Foods scientists inserted the leg hemoglobin protein gene from soy into the genome of the yeast strain Pichia pastoris, and extracted the protein by fermenting the yeast, harvesting its fermentation broth, and using ultrafiltration to remove extraneous compounds. Impossible Burger skeptics are most concerned about the safety of leg hemoglobin for human consumption. As a side note, I personally am confused by this because huge populations in Asia have been eating soy and its accompanying proteins for centuries without dying. Anyway, one valid basis for concern here is that leg hemoglobin produced by GMO yeast might be contaminated by other unwanted yeast proteins. Impossible Burger scientists themselves admit that the primary leg hemoglobin protein product only contains 65% soy protein, with the rest coming from Pichia pastoris. However, most of these proteins are analogous to proteins produced by the yeast strain Saccharomyces cerevisiae, which is widely consumed in many types of bread products. In vitro studies on yeast-produced leg hemoglobin show that it is neither genotoxic nor mutagenic. Additionally, in vivo animal studies conducted by Impossible Foods scientists showed no toxic effects on female rats over 28-day studies at doses that were even 100 times higher than a typical beef analog leg hemoglobin dose. A literature review also funded by Impossible Foods further indicates no allergenic or toxic effects of leg hemoglobin, indicating that it is likely very safe for human consumption. However, we also need to keep in mind that these studies were conducted by Impossible Foods researchers and that this is a somewhat controversial protein. GMO Science, for example, claims that the same Impossible Food studies previously described found and dismissed unexplained changes in weight gain and blood that could indicate inflammation, kidney disease, or anemia caused by leg hemoglobin consumption. Most recently, however, the US FDA determined that leg hemoglobin is safe for humans in December of 2019, representing a hopefully less biased and more solidly researched perspective on the protein. An analysis commissioned by Impossible Foods shows that the Impossible Burger produces 89% less carbon and uses 87% less water than the average beef burger. An Impossible Foods competitor, Beyond Meat, commissioned a study that found that pea protein Beyond Burgers generate 90% less carbon and require 46% less energy than a beef burger. While we should take this research with a grain of salt, these meat alternatives are certainly a step in the right direction towards building a more sustainable food system. Whether society is ready to take that step is another question.